Welcome to this Python Basics course on file system operations. My name is Martin, and I'm going to walk you through the course. Now, what are file system operations? Basically, it's the things that you do on a daily basis on your computer. It means creating files and folders, looking at the contents of a folder, searching for files and folders, and also moving and deleting files and folders. Those are all file system operations. You usually do them with your operating system, but you can also do them with Python. And in this course, you will learn how to do all these operations using Python's pathlib module. But before we go there, just for a second, why would you even want to use files and folders when you have something like the input function and also then terminal output? Why do you need files for programming? Now, I have three reasons for you. First is persistence. If you just run your program and you don't store the data anywhere in a file, your output is going to get lost when the program terminates. Second is convenience. If you need to input all the data that you want to use in your program, which might be a large amount, just by hand, then this is going to take you much longer than if you just load it from a file. And third is mobility. You might want to move your data from your computer to another computer, and this works really well with using files. Like I mentioned before, in this course, you will use Python's pathlib module to create files and directories, iterate over the contents of a directory, search for files and folders using wildcards, and also move and delete files and folders. Note that in this course, I will use the words folder and directory interchangeably. They'll stand for the same thing. Along the way, you will also learn about what files are, what the file system is, about some differences between Windows and Unix systems, about absolute and relative paths, about glob patterns for searching, about recursive matching, and finally also the shutil module. Here's the table of contents. You're starting off with this overview lesson. That's the one you're in right now. Next, you will learn about the anatomy of file and then about the file system. And then you already start getting a bit more practical. You'll learn how to create path objects, how to check whether a file path exists. You'll learn how to identify absolute and relative paths, how to resolve relative paths, how to access file path components. You'll also learn how to create directories and subdirectories, how to create files, how to iterate over directory contents, how to search for files using .glob, and then you will also understand some common wildcard characters such as the star, the question mark, and the square brackets that you can use with .glob. You'll learn how to search recursively, move files and directories, and finally also how to delete files and directories. And then the last lesson is going to be a summary, and I'll also point you forward to some additional resources that you can use to further your learning. Throughout the course, you will be using IDLE, which stands for Integrated Development and Learning Environment, and it comes with your Python installation. If you've gone through this whole series of Python basics courses, then you should be set up and running with IDLE. Otherwise, you can go ahead and check out one of these two resources on Real Python to learn more about how to use IDLE. And with that, let's get started on the Python Basics File System Operations course by learning a little more about files. Let's talk a little bit about files. Since you've been using a computer, you've interacted with files. You know probably that there's lots of different types of files. You've opened text files, watched movies from a movie file, and looked at pictures in a PNG or a JPEG format. And there's many other types of files as well. But what is a file really? As a programmer, it might be interesting to think about what's underneath all those different file formats. And the truth is that really all that a file is a sequence of bits. Down here, you see a sequence of bits. This would be a unit of meaning that's often 8 bits are grouped together as 1 byte. And this is what you see down here. You see 8 bits that's read from right to left. You have 0, 0, 0, 1, 0, 0, 1, 0. And that's a binary number. In an 8-bit encoding system, you have numbers from 0 to 255. If you think of them in a decimal system, and somewhere in there, in between, a couple of bits are switched on, 2 of them specifically here, and the rest are switched off. Now, I give you a moment. You can pause this video and try to figure out what is this binary number if you wanted to represent it in a decimal system. And if you don't care, just want the solution, then just keep watching. Here it is. This is the number 72 in the decimal system that we're much more familiar with dealing with. This number 72 encodes for something in a certain encoding format. And text files often use an encoding format such as ASCII or UTF-8. And in this format, 72 encodes for a character. So when your computer encounters this sequence in a file, the text program knows how to translate it to a character. And this is really what happens when you're opening a file. So if you open a text file that includes this sequence of bits, then you will see a character. Now, to exemplify this a little with an example, let's head over to idle. So I've written two small functions. We don't have to care about what's in there, but they're just going to read a text file and then print out bits and bytes and the numbers depending on which flags we're passing. So let me show you this. And I'll import it with an alias because it will be easier to type. So if I run print bits, then the function is going to read in a text file and show you the bits that it consists of. And here's your sequence of bits that makes up the content of this text file. Now, it's really hard to even know where does a unit of meaning start and end here. And different systems can also treat this differently. They don't have to necessarily group it in 8 bits to encode for some meaning, but this is a common way of doing it. So let's print them out in the unit of bytes. And for that, I have a different function. This function reads the same text file, but now it just groups the bits in there in units of 8. So now it's a little easier to read. And you may remember this number from the slide before. So this is the first character in this text file, and that's the number 72. So let's go ahead and print out the decimal representations of all of these bytes in there. As you can see, the first one is the decimal number 72, and then there's a couple of other ones. And these numbers in UTF-8 and ASCII, those are different encodings. They encode for text character data. And I can show you now finally what these characters are so that you know what's the content of this file that you're reading here. And here it is. The content of this file that is represented as this long sequence of bits as a text file encodes for string hello, comma, world, and exclamation mark. But now if you think about this, that every piece of data on a computer is stored as a sequence of bits. But now how to interpret this sequence of bits depends on an encoding and depends on what you do with the data that's there. You don't have to group them in units of 8, even though this is a common way of doing it. And this number, this binary number, does not have to encode for the character H. In different file types, it encodes for different things. But you as a higher level programmer, you don't have to really worry about these bits. Python has ways and libraries to handle movie data and image data and text data for you so that you generally don't have to interact with it on this bits or bytes level. But it's still helpful to know what's going on underneath. And the big takeaway here is really that there are many types of files, but under the hood, they all consist of a sequence of bits, and how they are read depends on the program and the programming and the encoding that you're working with. And that's part 1. In the next lesson, you're going to look at the file system and figure out what is a file system and how does it influence what is a file and how to read files. In the previous lesson, you learned what a file really is, that it is a sequence of bits stuck together, basically, and that it depends on the program and your computer on how to interpret these bits. Now, you need a way of handling all these bits that are saved on your storage. So if you want to revisit the file content that you saw in the previous lesson, this is the content of a text file that says, hello world, with an exclamation mark at the end. And it looks like this in bits, but now imagine this being stored somewhere on your storage disk. And then after it, maybe you have a PNG file. And this is just the start of an image file, but it just looks the same. You know, there's bits that are on and off, and they're just saved like this on the disk. Now, how does your operating system know that from here to here is where the text file is, and after it comes something else, you know? This task, that is a difficult task to handle, is done by the file system on your computer. The file system essentially does two things. It provides an abstract representation of files that are stored on the computer, which you can imagine as being some sort of a dictionary lookup where you have an abstract information of which bits you want to address, and then the file system redirects to those places in memory and gives them back to you to basically assemble the file. And then it also controls the storage and retrieval of that file data. So it interfaces with the hardware to then actually return these different pieces that can be spread out across the storage disk. So this is a whole complicated process. The good thing is you don't really have to worry about it because this is something that the file system handles for you, and Python just interacts with the file system and utilizes the functionality that's built in there. One thing to remember is that different operating systems use different file systems. There's loads of different file systems out there. So as you might see, you can run into a problem here that if you want to write Python code that works the same on different operating systems and interacts with files, that you could run into troubles there if this is handled differently. But Python has a good way around it, and you'll learn more about this coming up in just a bit. Now, let's think a little more about the file system. It is structured in a hierarchy. You can think of it as directories and files. So directories are containers for other directories or files. So in the end, you could think that there's a root directory, which is the first structure that holds all the other information. And then you can have multiple directories nested in there. You can have files, you can have subdirectories, and even more files. And this is what's called the directory tree. And now I'm going to show you a picture of the directory tree. Beautiful, right? Of course, this is not actually the directory tree. It looks more like this. Maybe like an upside down tree, where you have a root folder that sits at the very beginning. Then you have some other directories nested in there, and these directories can contain files, or they can contain other directories, which again contain files. This is an abstract representation of what's going on the storage device. Remember, it's all bits all the way down, basically, but you need some way of conceptualizing this and addressing these bits. And the file system gives you this option that if you wanted to, for example, find this reishi.gif, then you could address it like this. You would give it a file path that starts from the beginning, from the root, then goes into the next directory, photos, fungi, and then finally the name of the file. And this gives you the location, and the file system translates this path to the actual location of the data that is saved on your storage device so that you can access this image. Now you just learned that different operating systems use different file systems. And as a consequence, also the file paths are different on different operating systems. So if we look at a file path for macOS, it can look something like that, where the first / represents the root directory. Then there's a subdirectory called users. Then this is my username, my user directory. Then I go into the documents folder. And finally, there is a TXT file called hello.txt. On Ubuntu Linux, this would look slightly different. It starts again with a root directory, but then instead of users, you have a directory called home that contains the different user directories, and then again, documents and hello.txt. Windows is quite different to those two. The same type of file path would look like this, where you start off with a C:, and then a \, then a directory called users, then the username, documents, and the file name. And the main difference you'll notice here is that you start off with C:, instead of just a slash, as well as that all the slashes are backslashes instead of /. So these look quite different. You may think that makes it hard for you to write some code that finds a file in the documents folder, for example. But lucky for you, working with file paths in Python is relatively straightforward because of the built-in pathlib module. And you'll learn more about how to use it in the next lesson. The main interface for working with file paths in Python is the pathlib module. It is built in, but you will have to import it in order to work with it. You do that by typing import pathlib, and I will head over to an idle session to work alongside the things that I'll be talking about here. In the idle REPL, I start off by typing import pathlib, and it gives me access to the pathlib module. Now, what do you do with the pathlib module? Primarily, you're going to work with path objects. Those are objects that represent a file path on your operating system. And you can create them in 3 different ways. You can pass just directly a string in there that represents the file path. You can use path.home or path.cwd, which stands for current working directory. Or you can use the / operator, as well as another class method called .joinPath, which is equivalent to using the / operator. You will look at all 3 of these options in the coming lessons. And let's start with the one that might look the most straightforward, which is creating it from a string. I'm here on a macOS operating system. Let's say I want to represent a path that looks like that. It goes users, Martin, which is my username on this computer, then onto the desktop, and finally a file called hello.txt. This is the path I want to represent. Now, the quickest way to create a path object for this path is to pass in this value as a string. pathlib.path, and then I create a string, paste what I wrote up there in the comment, close the parentheses and press enter. And you can see that this returns a path object, just has the value of the specific path. Now you can see that it says POSIX path here instead of just saying path. And the reason for that is that I am on a macOS operating system that is a Unix-based system, like also Linux systems are. This is why it says POSIX path. If you were on a Windows computer, you'd get something like Windows path prepended to all of the paths that you create on that system. Otherwise, it looks pretty similar. However, if you are on a Windows system, then you might run into a problem. Windows paths use / characters instead of / characters to represent paths. And the / character in Python has a special meaning because it starts an escape sequence, which means that if you pass just a plain string with a /, then Python is going to not interpret the / character as a / character, but thinks that you want to start an escape sequence. This will break your Windows paths if you don't account for it, and you'll get syntax errors. There are 2 ways around it. You can either use a / instead, which means you can just represent a Windows path with the normal C colon, but then instead of using a / like you normally would, you just use a / instead. You can do that, and the pathlib library knows what to do with that, and then correctly creates a path object that points to this specific path. Another way of doing it is to use a raw string, and you can do that in Python by prefixing the string with just the R character. So you put this R in front of the string, and then you can use / characters like you would normally with a Windows path. Keep in mind that this is only relevant for Windows because on Unix systems like macOS or Linux, the paths anyways use this /, and that's not a reserved character for Python. Another way to create a path object is using path.home and path.cwd. Let's look at both of them, starting with path.home. This class method points you to the home directory on your computer. Now, these can be different things depending on which operating system you're on. Like I mentioned before, I'm on a Mac OS system. So for me, if I type pathlib.path.home, the path object that I get points to /users/ and then my username, which is Martin. If you're in a different operating system, it will point to a different folder. Let's look at the 3 different options that you're likely to encounter. If you're on a Windows system, then it will point to C:\users/ your username. If you're on macOS, as you just saw, it points to /users/ your username. And if you're on Ubuntu Linux, then it's going to point to /home/ and then your username. And in all of these cases, you just use path.home. So you use the same method in order to get different paths. And which path you get again, depends on your operating system. Now, you might already think about that this is a useful way of handling programs that should run cross-platform. If you do rely on, for example, creating a folder in the user's home directory, then you can use path.home instead of trying to hardcode any sort of value, which wouldn't work in the first place because people have different usernames, but also wouldn't work because of the different paths depending on the different operating systems. However, if you use path.home, then this will automatically use the correct directory for the specific user on their operating system. Path.cwd, which stands for current working directory, also creates a path object in a way dynamically. And in this case, it's a little bit different though, because path.cwd is a dynamic reference to a directory where currently a process is running. And this can change over the lifetime of a program, and it can also be different depending on where you're currently running Python. Let's take a look over in idle. If I run pathlib.path.cwd in my idle REPL, then I get back users, my username, and then documents. This is the default value that idle sets for the current working directory when you start it from your operating system's graphical user interface. However, that's not consistent across other runs of programs. As you just saw, when you're running idle, then usually this dynamic reference points to your documents folder. When you're running a script, then it usually points to the folder that contains your script. But keep in mind that this is a dynamic reference, so it might be a little hard to reason where it will point to during the run of your program. And because you can't control exactly how your users are going to run the program, this might also vary between them. So it's a little tricky. And there's a third point to it, which is that this value can also change over the lifetime of your program. If you do some sort of manipulations in your script, then the current working directory could be something else at the end of the script than it is at the beginning. So it is a bit tricky. Now you know how it works, and use it with caution. The third way to create a path object is using the / operator. And I can do something like typing pathlib.path.home and then concatenate another string by just using this operator that is a / and then followed up by a string. And you can continue doing this basically forever, as many pieces of the path you want to add. And in this example, so if you concatenate desktop and then again with the / operator, the string hello.txt, then again, you get this path object with the value that you've seen before, users Martin desktop hello.txt. Let's play around with this a bit more in the idle REPL. So you just saw on the slide that you can do pathlib.path and start off, for example, with my home directory. And then I concatenate desktop and then a file name hello.txt. And that creates another path object with the same value that you've seen before. Now, the interesting thing about this is that it's an operator, just like the plus in 2 plus 2 in Python is an operator, but it is specific to path objects. So you can use this / only if you have a path object at least one side of the operator. Otherwise, it's not defined and it won't work. And this functions in a way that it is a shortcut for another method on the path object that is called join path. So what it does, it calls pathlib.path.joinPath. Oh, I need to first create a path object. I do this using .home, as you've seen earlier. And then instead of using the / character, I can also say .joinPath and then pass in the string here, desktop. And then I can continue, join another path, hello.txt. Running this operation with .joinPath is the same as using the / operator. And you can see it produces the same output as well. So you can think of the / operator as a shortcut for this .joinPath class method on a path object. And it just makes it more convenient to quickly create paths. You do not have to put each part of the path as a separate item. So instead of saying pathlib.path.home /desktop /hello.txt, you could also say pathlib.path.home / and then put the whole rest of the path string in here. So you can say desktop /hello.txt, and that works just as well. So whatever you consider is the most readable for you, you can use here. Remember that the / is a shortcut for the .join path method, and that you can either chain multiple / operators or also join path methods with single pieces of the path that you want to create, or you can just add a path string on the right side of this operator as well. The important thing here is that this is only going to work if you have at least one path object part of the operation, which here you created by using the .home class method that we discussed in the previous lesson. Okay, let's quickly sum this up. You've now seen 3 different ways of creating path objects. The first one was from a string, where, keep in mind, with Windows, you'll have to do a little extra, either using / or using raw strings. The second option you saw was using path.home or path.cwd. And the third option you saw is using the / operator or the equivalent method .joinPath. And these are 3 different ways of creating path objects. In the next lesson, you'll learn how to check whether any of these paths and files that you addressed with path objects actually exist.